So in this video, we're going to be describing the transformation that maps y equals sine x onto each of these. Now, in this scenario, this one is actually going to be more straightforward, I think, than the previous two videos. The reason for that is because sine x is just in the same format as f of x. So sine of x is just a function of x, isn't it? So in that case, it has the same properties that if the minus sign is on the outside, then that must be a reflection that is affecting the y direction, okay? So if it's reflecting across the y, in the vertical direction, I should say, it's reflecting it across the x-axis. So this is a reflection in the x-axis. And here, I've put brackets in to identify that I've got a negative x inside. Okay, so if you've got minus x, then it makes sense to put a bracket around it because it looks neater. You're containing the minus sign. And that means that we've got f of minus x. If the minus sign is inside the bracket, it affects the horizontal direction, and it must be moving across a vertical mirror line. So that is a reflection in the y-axis. So we should be able to identify those relatively easily. But the reason why I've done this video is because of, let's have a think about what the graphs look like. Okay, so let's first of all sketch y equals sine x. So quick sketch, y equals sine x looks like this. So let's put a little bit to the left of the y-axis as well. Okay, so something like that. So here's 1, minus 1. This is 180 degrees, and that's 360 degrees. There's 90, and there's 270. Okay, so something like that. Now, if you reflect this in the x-axis, then the x-axis is your mirror line. So, what will the sketch now look like? So you might want to try and sketch it yourself so you can visualize what this should look like. So this part here will get reflected in the x-axis and will go down here. So the shape of the curve should now look like something like this. So that bit moves upwards, gets reflected upwards, and that bit gets reflected downwards. And so the remainder of the graph looks something like this. So this is 90, there's 180, 270, 360, minus 1, and 1. Okay? What if we now reflect in the y-axis? So go back to the original graph and we do a reflection in the y-axis. So here's your y-axis. We're going to reflect in that line now. So all of that's going to come over here, and all of that is going to come over here. Okay. So if I continue the graph a little bit, just so we can remind ourselves what's going on to the left of the y-axis, then I haven't drawn that particularly well. I'll have another go at that. Something like that. Okay. So reflecting the y-axis, all of that's going to come over here, and all of that is going to come over here. So what's that going to look like? Well, if all of that comes over here, this bit here will get reflected and will appear here, and this bit will get reflected and bounce over here. So we should get a curve that looks something like this. And this bit will get reflected over here, so it will appear over here. Okay, like so. So here's your 180, there's 360, there's 270, there's 90, there's 1, there's minus 1. And what graph does this look like? Well, it looks just like this one. So actually, what we've got to is the same graph. So a reflection in the x-axis and a reflection in the y-axis for the sine curve actually ends up with exactly the same graph, exactly the same shape. So the conclusion that you can make is that sine of negative x must be the same as minus sine of x. These two graphs are the same, and it gives you this identity, which is actually really useful, particularly for when you go up to the next level, up to A-level maths. So it's a good one to kind of like have on your belt, that you know that those two graphs will be the same.